So today's topic is work done by friction. So under that, we want to calculate the what is the work done by friction. So whenever I am saying friction, the friction may be static one and maybe kinetic one. Okay. So there are two types of friction, either is the static friction or the kinetic friction. Depending on that, the equation will be changed. Okay. So let's look at the situation. So let us there are two blocks. Let us there are two blocks and I am calculating the work done by the static friction. That means first, whenever I am trying to pull the block M1, so that means there is a static friction acting between M1 and M. So whenever I am pulling the block with the force M1, that means for that M1 block, M1 is trying to move in the forward direction. So that means on that M1 block, the friction will be acting in the direction static friction. And similarly, that Fs on the M1 block is giving another reaction force on Fs on the M2 block. So direction of the static friction is different for both the block M1 and M2. Okay. So if I want to calculate the work done by Fs on M1, and in the process, let us assume the entire block system is moved by a distance of S. Okay. So work done by static friction on M1 should be minus Fs into S. Okay. Minus Fs into S. Why? Because work done is the product of force and displacement. Now for M1, force is acting in the opposite direction and displacement in the forward direction. Similarly, if I want to calculate the work done by friction on M2, it should be positive. Plus Fs into S. So since both the displacements are equal, so I am writing over S here, there and here also it is S. So if I want to calculate the total friction, the total work done is always zero. So W net is becoming zero errors. Why? Because one friction is doing the positive work, another friction is doing the negative work. So ultimately total work becomes zero. Okay. So this is for the static friction. So one is basically for the M1, Fs is opposite direction. For the M2, Fs in the forward direction. So work done by Fs on M1 is negative and work done by Fs on M2 is positive. So ultimately we add these two numbers, this will cancel sign. Provided there is a smooth surface. Okay, so there is no friction on the bottommost portion of the M2 because it is a smooth surface. Only there are two blocks which are moving in combined because of static friction. Okay, so on individual particle of the system, static friction can perform positive or negative or zero work also. But as a whole, for the whole system, it is always equal to zero. Okay. That means what we can say net work by static friction effect is always equals to zero for the entire system. Once we consider the entire system combination of particle M1 and M2, net work is going to be zero. Okay. Now come to the kinetic friction. So whenever I am saying kinetic friction, that means now both the blocks are moving separately. Let us say the M1 is moved by S1 displacement and M2 is moved by S2 displacement. And we are assuming that S1 is greater than S2. Okay. So if M1 is moving in the forward direction, then the friction on this M1 should be here, to one Fk1. Okay. And because of that Fk1, there should be one Fk2 in this direction. Fk1. Okay. So both the kinetic friction will add, and because both are moving, so both the friction will differ. Okay. So if I want to calculate the friction by Fk1 on M1, so work done by Fk1 on M1 should be Fk1 into S1. Okay. Similarly, with the negative sign, so that is the work done on M1. Similarly, work done on M2 should be equals to plus Fk1 into S2. Okay. So this number is more positive, this number is less negative because S1 is greater than S2. So can I calculate the net work? Net work should be Fk1 into S2 minus S1, this number. Now this number is negative. S2 minus S1 number is negative, so work done will become negative. So in this situation, what is happening? One work done is positive, another work is again negative, but now they are not cancelling with each other. Why? Because the S1 displacement and S2 displacement are not equal. Depending on the S1 and S2 value, so on 1, friction is doing negative, Fk into S1. On 2, friction is doing positive work, Fk into S2, but these two values are not same. Yeah, these two values are not same, that's why they are not cancelling with each other. So there is one certain value that is here. So that value, since in this situation S1 is more than S2, that value comes to as negative. Okay. So total work performed by kinetic friction on the system as a whole is always negative, and it depends on the relative displacement between the contact. So what you understand from this is that whenever I am calculating the work done by the kinetic friction, that number is always negative. Why? Because ultimately what I am getting, this is the product minus Fk into S1 minus S2. What is S1 minus S2? That is the relative displacement. Okay. So that means what is I can write W equals to minus of Fk into S of 1, displacement of 1 which is 2. So 1 is displacing more than 2. That means this is the work done. That number becomes negative. Okay, so as a whole on the system work is always negative. Because there is some relative displacement S1 2 along the line of action of the friction. Because of that, work done is always there. That value is not equal to 0, but more precise, that value is negative. Okay, let us say there is a car which is moving with a velocity of 4 meter per second. Okay, and it has been given that the block, that is 2 kg block is there at its rest in just okay, so block is at rest. So block is at rest means here in this direction the mg sin theta component is there. Okay. So since the block is at rest, that means the friction is acting in this direction, which is equals to nothing but mg sin theta. This is balancing each other. So A become mg sin. Okay. Now what is mg sin theta number? That is equals to 20 into sin 37. So sin 37 is 3 by 5. So 12. So 12 Newton is the friction force. Now this pointer application of friction force is displaced by 8 meter in 2 seconds because the car is moving at 4 meter per second. So this is the force that is acting at the point with 12 Newton, and this point is displaced by 8 meter. Okay. So corresponding to this angle is 37 degree. Okay. So that means this angle is 180 minus 37. Okay. That means work done by friction over here is equals to how much? 12 into 8 into cos of 180 minus cos of 180 minus 30. Cos of 180 minus 30 is minus cos theta. So ultimately it becomes minus 12 into 8 into cos of 34 means 4 by 5. Okay. So minus 12 into 32 by 5. So that is the unit of work in negative term. Why? Because the displacement is in the forward direction and the force is somewhat in the inclined. Okay, that's why the angle is 180 minus 6. Okay, so work done by friction is this negative. Understood? Okay. Now, work done by the internal force. Let us say I am pulling one block, so there is a tug of war is going on. So this person is pulling this block in this direction. Let us say he is applying tension at point A. Let us say TB. The person B is applying the force as TB. Okay. So this TA and TB may cause the displacement of this block, depending on the which one is higher side. So because of that, there is a work done. Okay. Now I want to calculate the work done by the internal. Okay. So like the tension. So what tension is coming whenever I am trying to move the block B. So if I want to move the block with the force B, with the force A on block B applied, so then there is an internal tension that is being generated. So what you know that if the displacement of block B by S, so work done by this tension is negative. Why? Because force is acting opposite, displacement is in forward direction. But for this tension, the work is being positive. Now since both the blocks are moving in the same directions, so S remains same, so ultimately work done becomes okay. Now whenever the blocks are moving in such a way, now the friction is coming which is kinetic in nature. Let us say first block is moving with 10 meter per second and second block is at rest. So that means A is moving over B. So there is relative movement of A and B. So we can say that on the block A, that friction will be in this direction. So this is the friction force. And on the block B, the friction will be in this direction. But the friction is not sufficient to move the block B. That means work done by the friction on block B is zero because there is no displacement. B is not moving. But work done by the friction on the block A is a number which is not equal to 0. Why? Because for the A, there is a displacement. The A is moving in the forward direction. That means there is a displacement of the A block. But for the B block, there is no displacement. So work done by friction is not equal to 0. Okay. So there is not cancelling each other. So if the friction is kinetic, then only the friction force will not cancel each other. The work done is not cancelling each other. But here but I am saying that the friction is kinetic because both the blocks are moving separately. Okay. So total work due to internal force for the whole of the system may or may not be zero. Okay. It may be zero or may not be zero. That means I cannot say that it is always equal to zero. But resultant of internal force for the whole system is always why? Because the internal force comes whenever there is a movement. Okay, this tension will come only when I am moving the block B or trying to moving the block A. So then the T will come. Now, as a whole for the entire system, the tension is zero. Net tension force is zero, internal force is zero. As a whole for the entire system, net friction force is also zero. So that is why for the whole system, resultant of internal force is always going to be zero. So these forces do not contribute for net acceleration of the system. Whenever I am going to calculate the net acceleration of the system, so only for that situation this external force comes in the picture. Okay. So whenever I am applying an external force, if that force is responsible to create the acceleration. Why? No internal component will be there because the net internal component that is there, that is always equals to zero. Okay. But work done due to the internal force may or may not be, depending on the displacement is taking place or not. In this situation, what you understand that the work done by the tension is zero, but for the second situation, work done by the friction is not positive. Okay. Now, similarly, relative displacement of one body with respect to the other body along the direction of the internal force is always equal to. Okay. If it is true, that means if one body, let us say I am saying there are two block system, so you are pulling this block and pulling this block. Both the blocks are being pulled. Okay. So because of this, let us say initially the spring will be compressed. Once you release it, the spring will apply a force, spring force on this block and the spring force on this block. So since masses are different, so acceleration of the block M2 and acceleration of block M1 will be different. But net force is again going to be zero. Okay. So in that situation, there is a displacement, relative displacement of 0.1 and that means what you can say is relative displacement of one body with respect to the other along the direction of the internal force is zero, then only work is zero. Okay, in this situation, relative displacement is not equal to zero. Internal force will do work only when there is a reformation or deformation in the system. That means if I apply a force, then only a internal force will come. Internal force cannot come automatically inside the block. In order to get the internal force, you have to apply some kind of external. Now, whenever there is a deformation or deformation within the system, means a body is being deformed, now the deformation takes place. If the body is in the deformation situation, then it tries to go for deformation. In both of these situation, internal force will do work. But in case of rigid body, so where there is no deformation is being considered or no deformation, so work done by internal force is always going to be zero. Okay. So these are some of the important concepts. Now, very important concept comes from here onward, the dependence of work done on reference frame. Why? Because work done, so since we are discussing the work done by a constant force, and I am writing work done equals to force in dot displacement. Now we understand the displacement vector is relative. This is relative. Okay. So depending on which reference frame I am observing the particle, depending on that the work done will change. Okay. So magnitude of displacement of point of application of force. So what is the displacement? That displacement has to be considered at the point of application of the force, the point where I have applied the force. In a given time interval depends on the velocity of the frame of reference of observer. If the observer is in a non-inertial frame, then there is no issue. So if the frame is inertial, then only the displacement part is there. Okay. So that means the work is also dependent on the frame of reference. Let the block is there now inside the leaf and the leaf is moving out. So if I stand in this situation, now for me the block is in non-inertial situation. Okay. So in the non-inertial frame, I have to calculate the effect of pseudo force. Not only that, the displacement is also going to change. Okay. If I move inside the leaf, then the displacement of the particle will be different. If I go place myself in the outside. Okay. So outside means inertial frame. In inertial frame, I am calculating the work done and further I have to calculate the displacement. If I am inside the non-inertial frame, then the effect of pseudo force will come and because of that the displacement is also going to change. Okay. So let us do some situation over here. So to understand how to calculate the work done by the friction. So there is a two block system of mass 10 kg and 10 kg is given, and there is a friction coefficient of 0.5 is given in between the. We are pulling the entire block with a force of 100 newtons in the forward, and the upward part is the frictionless. Okay, so that means both the blocks are trying to move, in the forward direction because it's force. Okay, now you are asked to calculate the work done by the applied force during the displacement of 2. So in that situation, the friction will come. In that situation, the friction will come, but the magnitude of friction is purely dependent on the limiting value of friction. Okay. Now, what I am saying that both the acceleration of both the block must be same. Acceleration of both the block must be same. Why? Because I am pulling the entire system with the 100 Newton force. So acceleration for the system is how much? Then acceleration for system. I am not considering the internal force of the friction. So acceleration for system will be 100 by 20. It is 5 meter per second. Okay, 5 meter per second is the acceleration. Now, because of this acceleration, what is the force that comes inside this? So A body has the acceleration in this direction. B also having the same acceleration in the same direction. But on the A block, there is no force is being applied. So who is responsible to produce that acceleration? That is the friction. Okay. Now friction can produce, what is the limiting value of friction over here? So here the friction will be in this direction Fs. Okay. So if I say Fs is there, now corresponding to that, the limiting value should be equal to how much? Limiting value should be equal to mu into n, 0.5 into 100. That is 50 Newton. Okay. So 50 Newton force is applied on the block A, 10K. Okay. Because of that, the acceleration is given by 5 meter per second square. Okay. So if I draw the free body of the block A, so for A, friction in this direction, so Fm is how much? Fm is 50 Newton. Okay. Now similarly for the free body of B, so on B, the friction will be in the opposite direction. Again, Fm equals to 50 Newton. But there is another force of 100 Newton over here. Okay. Now you are asked to calculate the work done by the applied force. The applied force is how much? 100 Newton. Now this 100 Newton is producing a displacement of 2 meters. So work done is how much? 200 Joule. So first answer is 100 into 2. Because both are in the same direction. So I am calculating this work as the positive power plus 200 Joule. Okay. Now work done by the friction force on B. On B means forward direction. So on B means backward direction. So on B, friction force is acting backward direction. How much? 50. But the displacement is again 2 meter. So that means that is minus 50 into 2. Can I say that? That is minus 100 Joule. Okay. Minus 100 Joule. Okay. Net work by friction only. So friction is doing work on A and on B. So work done by friction on A. So it should be plus 50 into 2. Why? Because on A, friction is acting in the forward direction. So plus 50 into 2 means plus 100. Work done by friction on B is equals to minus 50 into 2 means minus 100. So ultimately total work done will be 0. Okay. The last part answer will be 0. Okay. So you have to understand the situation and then you have to apply the concept. So situation may be such that both the blocks are moving or one block is moving, other block is not moving, or they are moving separately. Anything may happen. Okay. Now let us say that there is a 10 kg block and there is another 10 kg block. Now upper one 10 kg block is moving with a velocity of 10 meter per second in the forward direction. The lower block is fixed. Okay. Since the upper block is moving, so I can clearly see that the friction on the upper block is this direction Fk, kinetic friction. And similarly on the lower block, the friction is in this direction F2. Okay. Okay. So what is the Fk number? Fk equals to mu, that is 0.1 into 100, that is 10 Newton. Okay. Now this 10 Newton. Now you are asked to calculate the work done by the kinetic friction on A and B. On A and B. Okay. So due to that Fk on A, what is the retardation period? So you are asked to calculate the work done by kinetic friction on A and B separately, but and the second part is also you have to calculate the net work done by the friction on the system till the two blocks stop slipping. So what is happening over here that due to the friction force on A, the velocity of A is going to reduce. Now, due to the friction on B, velocity of B block is initially 0, ultimately we gain. Why? Because the lower part is nah. So B block is moving in the forward direction, and ultimately A block is also moving in the forward direction, but gradually the velocity will be reduced. So first of all, you have to calculate the work done by the friction on A and B. Still, that two blocks stops. Okay. So first of all, you have to understand when the two blocks will stop. So for the A block, retardation in this direction. So what is the value of retardation? A can be written as 10 Newton is the friction force and divided by 10, that is 1 meter per second square. Okay, 1 meter per second square. So ultimately, the velocity of this particle is going to be 0. Going to be 0. But we are asked to calculate till they are stopping slipping. That means after some point at time, let us say the block A is moving with a velocity v naught. Now, after that amount of time, so V is increased speed. Why? Because V block is moving with some acceleration. What is that acceleration? Because this force Fk, that is 10 by 10, acceleration is again 1 meter per second square. Nah. So V is moving forward with some acceleration and A is moving forward with some retardation. So ultimately, after some point of time, both are acting in the same speed. When they are acting in the same speed, that means here also I am saying the V block is moving forward with velocity v naught. Now at that point of time, the slipping will stop. Now I have to calculate what is that time. Now after time t naught, v naught should be how much? 10 minus 1 into t. Nah, 10 minus 1 into g minus u minus at. And here it should be equal to 0 plus 1 into t. That means what you can say, 10 minus t should be equal to t. That means t should be equal to 5 seconds. After 5 seconds, both the block will attain the same speed. And what is the speed? That is 5 meter per second. And till 0 to 5 seconds, there is slipping. Till 0 to 5 seconds, there is slipping. You are asked to calculate the displacement in that situation. Now, in 5 seconds, so in 5 seconds, what is the displacement of A block? If I say SA, that should be equal to UAT minus half AA into T square. Now what is UA? UA is 10, T is 5 minus half into 1 into T square means 5 square. So ultimately 50 minus 25, that means 25 meter. Yeah, 25 meter. Okay. So 25 meter is the displacement of particle A. Similarly, I can say the displacement of the particle B also. So displacement of particle B, that should be the A simply half AT square, ABT square. What is A? Half A is 1. No, 25 by 2. Not 25 by 2. So 100 minus 75 by 2, 37.5. No, this is not 25. So this 5 is 25 by 2. 50 minus 25 by 2 means 75 by 2. Okay. So then it is 25 by 2. Is the 25 by 2 meter. Okay. Now once I calculate the displacement, so both are in the forward direction. Both are moving in the same direction. So both the directions are forward, but friction force on A is negative. So work done by friction on A should be how much? Minus 10 into 75 by 2 means minus 375 joule. Okay. Similarly, work done by friction on B is how much? That is equals to plus 10 into 25 by 2 means plus 125 joule. Okay. So now add this to that with the net. So these are the typical problems where you have to apply the concept. Okay. So what is asked over here, you are asked to calculate the net. So last line is very, very important. So what the last line says, that the work done by the friction on system till two blocks stop slipping. Okay, that means from here you get the information of time. What I am doing, so initially the block A is moving with 10 meter per second and block B is speed. It is not moving. So because of friction on the block B, that is in the forward direction, it will start to move. And because of friction on the block A, it will retard. Now, friction value is how much? That is kinetic friction, that is mu into n, that is 10 Newton. Okay. So this 10 Newton force will create retardation on block A as 10 by 10 means 1. And that same 10 Newton force is creating acceleration on block B. So because of these two forces, friction forces, so block A will gradually reduce its speed and block B will gain its speed. So what I am saying that initially the block A is moving 10 and finally it will attain a velocity of V0. Similarly, after some time, again the block B will also attain the same speed V0. If both are moving the same speed, that means what I can say, the blocks move in combined movement and mean they stop sleeping. So that means first of all, I have to calculate this V0 number. So what is the V0 number? That is 10 minus 1t for the A block and similarly 0 plus 1t for the B block. So if I equate these two, I got that t equals to 5 seconds. That means after 5 seconds, both the blocks are moving with same speed. That means they stop sleeping. Now, next we calculate what is the displacement of the block A in 5 seconds. Similarly, I calculate the displacement of block B for 5 seconds. Now we calculate the work. Once I calculate the work done, so one work is negative, another work is positive, and most importantly, net work is bound to be negative. If you got this number is positive by any means, okay, that means your answer is right. Okay, so net work is always negative for the kinetic friction point. Got it? Understood? So this is the idea behind this problem. So everything you have to be very careful about this. So you can apply this concept and ultimately get the answer. Okay. So moving on to the next situation. Again the blocks are there. So 10 kg block slides down an inclined plane of 5 meter long and 3 meter high. It is coming down an inclined plane. Now it is being given that it slides down. That means the block is moving down. A man pushes up the block parallel to the incline so that it slides down at constant speed. Okay. So initially what is happening, let us do one simple calculation. So in this situation, if this is 3 and this is 5, so can I say this angle is 37 degree? Yes. Because sine theta is 3 by 5 means 37 degree. So because of this, mg sine 37 is acting downward. So what is that mg sine 30? That is 10 into 10 means 100 into sine 37. 100 sine 37 means 100 into 3 by 5, that means 60. So 60 Newton force is acting in this direction. And similarly, this force is 80 Newton normal. Okay, this is the 80 Newton normal. So I got the answer for normal as 80 Newton. Now based on this normal number, what you can calculate first? So first you calculate the what is the limiting value of friction. Limiting value. So limiting value of friction is how much? Limiting value is equals to mu into n. So mu is 0.1 into 80 means 80 Newton into 0.1. That means simply 8 Newton. So 8 Newton cannot hold this block fixed. Okay. So the block will eventually come down. So friction is acting in this direction. Now if you create an acceleration for this. But now the question says that the block is moving and a man is pushing the block up. So that means he is applying a force in this direction. This is the external force applied by the man. Such that the block is moving with constant. That means the acceleration is 0. Now if acceleration is 0, that means now we can conclude the net force is also equal to 0. So that means 60 should balance by capital F plus small f. That means 60 should balance by capital F plus small f. So what is small f? That is 8. So capital F is becoming how much? 52 Newton. Okay, so this is the information that is got from this problem. Now, what is asking that the work done by the man on the block. Work done by the man on the block. Now, what is the displacement? So it is down the plane by 5 meter. Down the plane by 5 meter. So man is applying a force of 52 Newton. Okay. And displacement is in the downward. Why? Because it has been said that the block eventually comes from point A to point B. Okay. So what is the displacement? ASAB. ASAB is 5 meter. Can I say that? And the force by the man is applied in this direction. If the force applied by the man, that is equals to I got at 52 Newton. And the displacement of the point is in this direction. It is 5 meter. So work done by the force is going to be negative 1. So work done by man should be equals to work done by man should be equal to minus 52 into 5. That is minus 262. Okay. Now the work done by gravity. So gravity is acting downward. So that is the mg number. That is the work done by gravity. So in order to calculate the work done by gravity, always you have to check the vertical displacement. So vertical displacement for point A to B is 3 meter. Okay. Now what is mg? Mg is 100 Newton. So 100 Newton is moving downward by 3 meters. So work done by gravity So this is the first part. Second part is work done by gravity, mg. That is equals to particle is moving downward. So particle once moving downward, then work done by the gravity is going to be positive one. So 100 and vertical distance 3, 300 joule. Okay. So third one is the work done by the surface on the block. Surface is how much? So surface is acting a frictional force, and that frictional force is basically the static. Got it? So work done by the surface. So the particles always rest in terms of surface. So work done by the surface. So one force is positive, another force is negative. So for the surface, if I say for the surface, so for the surface the friction is induced. For the block, on the block the friction is induced. The net friction force work is how much? 0. Okay. So that is going to be 0. So work done by the resultant force on the block. What is the resultant force? So one force is capital F, another force is small f, another force is Q. These are all cancels out. Okay. So net force acting on the particle is basically our 60 Newton, capital F and small f. Okay, this force. So net work should be equals to how much? So work is, so I have already calculated the work for the capital F. And I already calculated the work for the mg, and friction not doing any kind of work. So what I can say that net work should be equals to work done by gravity plus work done by man. So 300 minus 260, that is 40 joule. That is your answer. Okay. So work done by the resultant force is equals to 300 minus 40 joule, 40 joule. Okay. So this is the type of problem you have to face, that various forces are there, and concerning each and every force carefully, you have to calculate the work. Okay. Now come to this. Okay. So this is an accelerated block system. Now block of mass m is suspended from an elevator which is moving up with an acceleration a. Okay. Find the work done during the first t second by the tension force in the. Now first of all calculate the what is the tension. So if I observe from the this man who is in the non-inertial frame, so for that I should apply the pseudo. So if I apply the pseudo on this block, so pseudo should be in the downward direction. So downward direction, M1 is mg, another is ma. So tension force should be equals to, for this non-inertial frame, is equals to mg plus a. Okay. Now similarly, I can calculate the tension force for the inertial frame also. So this man is standing on the inertial frame. So tension force based on inertial frame should be equal to how much? So for the person who is sitting on the ground, he is observing that the particle is moving with an acceleration up. Okay. So what you can write, T minus mg should be equal to m into a. So ultimately I am getting the same answer as mg plus ma. So the force is not going to be changed based on the whether I am seeing from the inertial frame or the non-inertial. Okay. Now come to the displacement. So displacement has to be there. So first of all, you are asked to calculate from the reference frame of the ground and from the reference frame of the elevator. Okay. So if I come to the ground part, so the man who is standing on the ground, he is seeing that the block is moving upward with an acceleration. Now, he is seeing the block is moving upward with an acceleration a. So for this person, so for the frame of ground, can I say the displacement is equals to half at square in the upward direction in time t? Okay. Now for this man on the ground, tension is also in the upward direction. So what is the work done? T into this number. Okay. So work done by the man on the inertial frame of reference, can I say m into g plus a is the tension force multiplied by half at square. That will be your answer for the work done by the man in the frame of reference ground. Okay. Now from the reference frame of elevator, now the person who is in the elevator, he is at rest. So for this person, the displacement of the, so what, why? Because the person who is in the elevator, for which the acceleration of the block is 0. Now, if the person is in the elevator, so elevator is moving with an upward acceleration, so the person's acceleration is also a. So with respect to that person, the block is at rest. So displacement of the block B, let us say I am giving the block B as a name, with respect to the person who is in the elevator, A. That should be equal to how much? That should be equal to 0. Why? Because there is no acceleration. Okay. Because it is half at square, because it is half at square means 0. So it is 0. So tension is not equal to 0. Tension of the block with respect to the person in the element is not equal to 0. So that means the work done by the tension with respect to the elevator person is equal to 0. Understood? This is very, very important. Very, very important concept. Why? Because whenever I see the object, so depending on the two reference frame, I am getting two different answers. So it clearly suggests that the work done by the external force or the internal work done by any force is dependent on frame. Okay, by choosing the reference frame, I can take the correct value of the work. So one work is positive work I am getting from the ground frame, but whenever I see the same object with respect to the elevator frame, I am getting the answer to be 0. Why? Because with respect to elevator, the block is not moving at all. It is at rest. Understood?
Yes.
Now come to this situation. So there is a okay. Let us say in this situation there is a block of mass 10 kg pulled by a force of 100 Newton. Let us say this is the P particle. You are pulling the particle P with a force of 100 Newton, and because of this force, there is a displacement of 500 meter in 10 seconds. 500 meter in 10 seconds. Now the motion of this particle P is observed by three different observers A, B, and C. We are asked to calculate the work done by force in 10 seconds as observed by A, B, and C. So once you are applying a force, then the particle is displaced by 500. Very good. So that is the displacement of the particle P is equal to 5 meters. Okay. Now with respect to A, so A is at rest, acceleration is also 0. So corresponding to that, what you can write, the displacement of A is also 0. Okay. So corresponding to that, what you can write, displacement of particle P with respect to A is 500 meter. Okay. So work done by force as seen by the particle observer A should be equal to force into displacement by of P with respect to A. It is how much? 100 into 500. That will be your answer. Okay. That is the observed work done by the person A. Now for the person B, he is moving with 10 meter per second. Okay. So the particle is displaced for 10 seconds. So in 10 seconds, displacement of B is how much? dt. That is equals to 10 into 10 means 100 meter. Now, so the particle B of the observer B is displaced by 100 meter, and in the same time the particle P is displaced by 50 meter. So can I say displacement of P with respect to A is 400 meter? Now, so the work done in this second situation is equals to force remains same but displacing 400. That is the answer for the second situation. Okay. In the third situation, what happens? Now the observer is moving some kind of acceleration. Now the observer is moving some kind of acceleration. So with that acceleration, can I say displacement of particle C should be half at square? So that should be equals to half into 10 square means 100. So that means 500 meter. Okay. So displacement of the C is 500. Displacement of P is also 500. So can I say displacement of P with respect to C is 0? So work done by the force A as seen by the particle C, observer C, that is going to be 0. Okay. So it clearly says that the work done is dependent on the situation. As seen by the observer, who is seeing the particle to move. So once the particle is seen by the observer A, who is at rest, then I calculate the displacement with respect to A. Once the part I see the observer B who is moving 10 meter per second, now we calculate the displacement with respect to B. Now finally I calculate the displacement with respect to C. So this displacement number is going to be defined. So what is basically force into displacement? Okay, force into displacement. So that means force into displacement, that displacement is the relative quantity. So force into displacement of the particle with respect to observer. So that number is going to be changed. So since that number is going to be changed, so work done unfortunately is also going to be changed. The value will be different. Okay. The value cannot be same. Understood? Let us see this situation. So a 5 kg block is kept in a horizontal platform at rest. So initially it is at rest. T is equal to 0. At time t equals to 0, the platform starts to move with a constant acceleration of 1 meter per. The platform is moving with an acceleration of 1 meter per second square. Find the work done by the force of friction on the block. In the fixed reference frame in 10 seconds, when the coefficient is either 0.2 or 0.3. Okay. Now, if the belt is moving with 1 meter per second square, now the block has to move also with 1 meter per second square in this direction. Okay. Now, in order to create that 1 meter per second square acceleration, there must be one force. So, that force is how much? So, for creation of this 1 meter per second square acceleration, the force required is how much? Force is 5 into 1, that is 5 Newton. No, 5 Newton. So, 5 Newton is the force of the required. Now, check what is the friction over there. So, friction is how much? Limiting friction is how much? Limiting friction on 5 kg Fm is equal to mu into 50. So, mu is given as 0.2 into 50. That means 10. Nah,
Yes.
10 Newton. So, friction force is 10 Newton. So, limiting is 10. But the requirement of friction is how much? Requirement of friction is 5. Nah. So, in order to
Yes.
produce the 5 Newton force, the requirement of friction is 5. So, on 5 kg block, now we apply a force which is equal to 5 Newton. Okay, because that force friction is less than the requirement of friction, less than the limiting value of friction, less than the limiting value of friction. So that is 5 Newton can be applied. So friction on 5 kg block becomes 5 Newton. And because of that, what is the displacement? Because of that, the displacement of 5 kg will be how much? In 10 seconds? In 10 seconds, the 5 kg will be displaced by half at square. Half at square.
Yes.
So half a is 1, t square is how much? T square is 100. That is 50 meter. So 50 meter is the displacement of the point of application. Now, in whose direction the friction is applicable? That you have to also consider. So friction is acting in this direction on the block. Okay. So 5 kg is moving by a friction force in this direction, and on the belt the friction is acting in this direction. So both the points are moved ahead by how much distance? 50 meter. Okay. So you are asked to calculate the friction by on the block. On the block. So on the block is F. So work done by this F is how much? Work done by friction will be 5 into 50. That is 250 joule. Okay, that is your answer. Okay, if you calculate the net work will be going to 0 because this friction is cancelling the other one. Okay, now the second situation, again the acceleration is 5. So for the 5 kg block, requirement of this force has to be equal to 5 Newton. That is understandable. Now check the limiting value. So what is the limiting value? Limiting value is 0.02 into 50. That is 1 Newton. But your friction requirement is 5. So I cannot give 1. So here the friction will be equals to 1. Okay. Here the friction will be equals to 1 because once I am applying a 5 Newton force, because I am not applying force 5 Newton. Why? Because I am giving the force, acceleration is 1 meter per second. So I am assuming that both 5 kg and the belt are moving combined. But in the second situation, when the friction coefficient is 0.02, in that situation, what happens? The limiting friction is 1 Newton. So on 5 kg maximum, I can apply 1 Newton of. On 5 kg, I can apply maximum. So now the friction is 1. Okay. So correspondingly, acceleration is how much? Acceleration is equals to 1 by 5 meter per second square. So what is the displacement of 5 kg then? So 5 kg will be displaced. S of 5 kg if I say is equals to how much? That is half 80 square. 1 by 5 into t square means 100. Okay, that is 10 meter. Now the part will be displaced by 10 meter under the application of force of 1. Okay, here the friction is 1 Newton and the displacement of the point is 10 meter. So work done by the friction is how much then? That's equals to 1 into 10, that is 10. Okay. So whenever you reduce the friction, whenever I reduce the friction to 0.2 to 0.02, then the work is also going to reduce. Why? Because in the first situation, friction is 5 Newton is possible. because that number is less than limiting. But in the second situation, I requirement of friction is 5, but 5 cannot be given. So that's why I am giving the 1 Newton friction force. So once I am giving 1 Newton friction force, corresponding to the acceleration is 1 by 5. Now what I am saying that now the both the belt and the mass is moving different. Nah? So with respect to belt, mass is moving in the opposite direction. Why? Because acceleration is less. In the second situation, so on the block, so this block is moving with A equals to 1 by 5. But this is moving with A equals to 2. Okay, so with respect to block, with respect to belt, the particle is moving in the opposite direction. Now, with respect to block, the particle is moving in the opposite direction. Okay, so this is the way you have to think and calculate. Now come to this type of problem, where there is an observer and a vehicle. Both start moving together. So this is the vehicle and an observer. Both are moving with some kind of acceleration 2 and 5. So okay, there is a 2 kg block is resting on the vehicle on the floor, and there is a coefficient of friction is 0.33. So you are asked to calculate the work done by the frictional force on the 2 kg block as observed by the running object in the first 2 seconds. Now first of all, you have to identify what is the friction force at. Now since the entire block, entire card is moving with 2 meter per second square, so if I assume the 2 kg block is also moving with 2 meter per second square acceleration. Okay, so what is the requirement of friction then? Force is 2 into 2 is 4. So I should apply a force of 4 Newton on this particular system. Now, so in this case, F requirement is 4 Newton. Now you have to check whether you can give 4 Newton or not. So for that, calculate the limiting value. So what is limiting value? That is 0.3 into 20. That means 6 Newton. Now requirement of friction is less than Fn. That means this is possible. So on the block, 4 Newton force of friction is there. Okay. Now you are asked to calculate the work done by the friction force. What is that friction force? That friction force you got as 4 Newton. Okay. As observed by the running man. So since I am willing to calculate with respect to some other, so now I calculate the, let us say this is the P block, this is the observer O. So acceleration of P with respect to O should be how much? Acceleration of P as seen by O is 2 minus 5. No, minus 3 meter per second square. Minus 3 meter per second square. So minus 3 meter per second square is the acceleration of the P block with respect to observer. So with that acceleration, what is the displacement in 2 seconds? So displacement of the particle P with respect to observer should be equals to half at square, half into minus 3 into T square. T square means how much? You have to wait for how long? 2 seconds. So that means minus 6 meter. Got it? So minus 6 meter is the displacement as seen by the observer. So with the displacement, what is the force? I have already calculated 4 Newton. So work done by the friction is how much? Work done by friction should be equal to 4 into displacement minus 6. This is minus 24. Got it? So that will be the answer, minus 24. So be very careful about solving this type of problem. Very, very careful. Because you have to understand the frame, and then based on the frame you have to calculate the displacement, and also you have to take care about the friction. Okay. Now solve the previous problem when the man runs in the opposite direction. So for the same situation, I want to calculate the friction again. So requirement of friction is now, as per the previous problem, requirement of friction is that is 4 Newton again, and that is less than the limiting value. So I can give this 4 Newton force. Okay. Now the with respect to observer O, the displacement acceleration of P with respect to O is how much? 2 plus 5. Now AP minus A is 2 plus 5 means plus 7 meter per second. Okay. That means the P is appearing to move with plus 7 meter per second towards the observer. So corresponding displacement of particle P with respect to the observer is how much? Half into 7 into 4 means 14 meter. No, 14 meter. So since the displacement is 14 meter, friction is how much? Friction is 4. So what is the work done? Both are in the same direction. I am getting the positive number. So here the work done by the friction should be how much? 4 into 40. Then 56. Positive number. Okay. So in the same question, if I reduce the friction constant, let us say I am now giving a value of not 0.3. Let us say I'm giving a value of 0.1. Let us say I'm giving a value of 0.1. Now, requirement of friction is 4. Now, what is the FM? FM become 0.1 into 20. That means 2. Nah, 0.1. So, friction becomes 2. So, with that friction force, so 2 Newton should act. Okay. Now, the friction is 2 Newton. So, since the friction is 2 Newton, now the block will slip. Okay. So, you have to repeat the calculation with the friction force as 2 Newton. Understood? So, corresponding to Newton, what is the acceleration? 1 meter per second square. Block acceleration is not 2. Now it is 1. Okay. And accordingly, you have to change your entire calculation. Okay. So, this is all about to calculate the work done by force, which is constant first of all, and also the variable. In what direction? Depending on the frame. Okay. Now we go into the second part of the discussion, that is the work done by variable. So far, you identify the work done by the constant force. Now you are going to look at the variable force. So a force is said to be variable when its magnitude or direction or both are changing. Either the magnitude is changing or the direction is changing. In that situation, the force is said to be variable force. A particle moves along a path AB under the variable force. That's true. Okay, let us say the particle moving along AB under the variable force. At any instant, you say that force is making an angle theta with displacement vector dx. So from point, let us say small a to small b, you are moving the particle, and in that situation, you are moved by a displacement of ds. So in moving the particle from point A to B, you are doing a small work, that is dw, that is equal to what? F dot ds. Okay, but since the force is variable, so you cannot do this. So you have to integrate. So total work should be how much? Integration of dw, that is equal to integration of F dot ds. Okay. So this is the proper format to calculate the work done by the force, which is variable in nature. Now the variation may be either position, with respect to position, how the force is changing, or with respect to time. Depending on that, you have to formulate your problem set. Okay. So this is the small work done, and ultimately you have to integrate it to get the total work. Okay. So once you do the integration, so finally I can get the total work done. So whenever the particle is moving, whenever the particle is moving, if I say the particle is moving from, let us say, this point to this point. Okay, in this direction. Let us say this is the r vector. Okay, this is the r vector. And I am saying that this position is changing with respect to some kind of force acting on the particle. And let us say that force is in this direction. And that force may be constant, may not be constant. Okay. So in order to move the particle in a particular path, I have to go for the work integration. Okay. So if I calculate the dw number, so what is the dw? F dot dr. F dot dr vector. Okay. So what is dr? Dr is the displacement vector corresponding to the requirement of F. What is the meaning? Meaning is that, let us say F is a 2D vector. F is a 2D vector. Okay, 2D vector. Now for that 2D vector, you have to write dr vector as dxi plus dy. Got it? So if the vector is 2D, then write dr vector as dxi plus dy. If the vector is 3D, then instead of writing dx and dy, you should also write the dz component also. For the 3D vector, you should write the dr vector as dxi plus dyj plus dz. That means you are moving in 3D position. That means you are moving in this direction first dx, then dy, then dz. Okay, this is the dx component, this is the dy component, and then the dz component. So that depends on the situation. Whatever the situation, depending on that, you have to calculate your dr vector. Okay. So first you do the calculation based on the force, which is variable with respect to position. Okay. If is given as 2x plus 2 and the particle is displaced from point A to B, you are asked to calculate the value. So you know that dw should be written as F into F vector dot dr. Okay. Now since F is 1D vector, it is written as 2x plus 2 and that is along x direction. So if I write F vector as 2x plus 2i, dot dr is basically dx into I. Nah. Because F is a unidirectional vector. Along x direction the force is applicable. So I write 2x plus 2I dot dx. Why dx? Is only one single vector dr. So dw becomes how much? 2x plus 2 into dx. So finally I have to integrate. So work done should be equal to how much? Integration of 2x plus 2 dx. Now return the limit, x is 0 to 5. Initially at point A, x is equals to 0. Once I reach at point B, x equals to 5. So you have to take the limit from 0 to 5. So ultimately your answer is 2 x square by 2 plus 2x. Okay, that means x square plus 2x. So put the limit of 0 to 5. So 25 plus 2 into 5 is 10 is 30. So 35 joule will be your answer. Okay, so this is a variable force, and for variable force you have to do the integration everywhere. Now, similarly, another variable force of interesting part is the spring. Okay, why? Because depending on the amount of extension, it is the natural length. So from natural length, you are extending the spring by x distance. So spring force will be kx force, which is variable. Okay. Now I want to calculate the work done by the spring. Okay. So you are displacing the particle in the right hand direction. The spring force is acting opposite direction. So can I write dw should be equal to minus kx into dx? Why? Because at x position, the force is minus k. Now from this x position, you are slightly displacing the particle by dx distance. Okay. So dx is positive and force is in this direction k. So that's why I put a negative sign. So this is a small work done by the spring. Just one second. Hello. হ্যাঁ, আচ্ছা, ঠিক আছে, দেখি যদি দুটো বাড়িতে যাচ্ছি না ক্যালকুলেট করছি। হ্যাঁ, ঠিক। So spring force is acting opposite direction and displacement in the forward direction. So work done, small work done is minus k. So total work done should be integration of this. So once I do the integration, minus k take out, integration of x dx, limit from 0 to x. So this is minus kx square. Okay, minus kx square by 2. So if I put the limit not from 0, why I am putting 0? So if I start from natural, so I am extending the spring from natural length to the elongated position x. Now let us say I am moving the spring from x1 position to x2 position. So both are possible. So for that, what is the work done? So for work done, it should be equals to minus k integration of x dx, but the limit should be from x1 to x2. Okay. So to be minus k x2 square minus x1 square by 2. Okay. So this is the answer. So whenever I am elongating the string from x1 to x2, negative of k x2 square minus x1 square by 2. So this is the work done by spring force. Now in order to extend the spring, you must have to apply the force. So as an external agent, I am applying the force in this direction. So external force is always positive. So external force is how much? That is kx. So similarly, what I can say that work done by the spring force is work done by spring. So work done by external force should be equal to how much? Negative of work done by the spring. Okay, because of plus kx square by 2. Okay. So if I extend the spring from x2, x1 to x2, work done will be by the external force. So in this situation, if I want to calculate the work done by external, so external should be, so only thing is that you replace the negative side. So half of k into x2 square minus x1 square. That will be your answer. Okay. So in the spring problem, so whenever I am displacing the spring from the equilibrium position, so whenever I displace the spring in the forward direction, in this direction, so x is positive. If I compress the spring, that means x is negative. Okay. Once I make the x to be positive, that means elongation, the spring force will be moved. This is the spring force. So opposite to that force, the external force is there. So external is in this direction. So whenever you are compressing the spring, so spring force goes in this direction. This is a spring force. But opposite to that, the external force is there. Okay. So external force is always opposite to the spring force. And what is the expression of the spring force? Every time I write the spring force as minus kx. Why minus? Because it is If I say x is positive, then fx become negative. This is the negative sign. If x is negative, then fx become positive. So that's why you have to put a negative sign to define the spring force. So if I write the spring force with a negative sign, so F external should always be written as the plus Fs. Okay, plus Fs. So if Fs is negative, then always become positive. If Fs is positive, then it will become negative. So this is the idea to write the spring force. So whenever the particle is natural length, so from natural to elongated position, if I want to do the extension, so work done by the spring force is how much? Spring force should be equal to minus half AX. Okay. So from elongated to compressed means you are elongating this position. So this is our x1 location, and finally you are getting x2. So both x1 and x2 are to be measured from the natural length. Okay. So from the natural length position, let us give the x number, give the x2 number. So what you understand that for this situation, work done by the spring force has to be written as minus k by 2 into x2 square minus x1. What is x2? X2 is the final. So final is x. Initial is also x. So can I write minus k by 2 x square minus x square? Nah. So x2 is what? X2 is the final compressed position. And x1 is the initial elongated position. So here the work will become easy. Okay. So from natural length, if you are moving towards either compressed region or elongated portion, there is a work. But from this position to this position, there is no work. Because one work is positive, another work is negative, ultimately we can. Okay. If I compress the spring from this point to that point, then also the same work. Because the work done expression is equals to minus half kx square, taking the limit from 0 to x. Okay. So this is the final expression. The work done by the spring force is minus k by 2 x final square minus x inverse square. So I have written this number is x2 and this is as x1. Okay. So x2 square minus x1 square. And every time x2 and x1, these numbers are to be taken from the natural. This is the spring natural is this one. So from natural we take the value of x1 and from natural we take the value of x2. Okay. So final minus initial but with a negative sign. There is a work done by the spring force and negative of that number will be the work done by the external force. Okay. Now looking into this expression, so what I can conclude that whatever is the value of x, so that number is always negative. Nah. So work done by the spring force is negative. If I calculate the situation, let us say so for this expression, if I elongate, so if I say from the natural length position, so this is the natural length position. From natural length position, I have extended the spring by x, or I compress the spring by x. In both the situation, work done is negative. Nah. Because minus half x square, starting from 0 limit is always same. So if I put the x square value, so it is either positive or negative in material because it is always going to be positive. So it is negative from natural. But if I consider the situation that final is more than 11 initial, x2 is greater than x1. In that situation, it is negative because work done by the spring force is equals to minus k by 2 into x2 square minus x1. Okay. Since I say that x2 is more, so it is negative. If both are same, it is 0. Okay. If both are same, it is 0. And if it is x2 is less than x1, then it is positive. x2 is less than x1, that is positive. Okay. It depends on the situation. So work done by the spring force depends only on the initial and the final deformation. That is x1 and x2. In most of the situation, I can take this x1 number as 0. In most of the situation, I take this x1 number is our natural length position. That means this number is only I go for the x2 calculation. So once I know the x2 number, then I can calculate the work in the spring force. Now, so this is the final situation. Work done by spring force is this one. Let us say I am elongating the spring. From x2 to x1. x2 to x1. So moving the spring from B to A. So if I move the spring from B to A, work done is how much? Work done is basically final minus initial. Work done is final minus initial. So for this situation, if I from this to this, if I want to create a situation from x2 to x1, so x1 becomes final x to become initial. So work done in this situation will be minus k by 2 final square. Final is one x1 square minus x2. Okay. Now if I create the situation like this way, in from this to this, so x1 will be compressed and x2 is elongated. Okay. So in this situation, what is the work done? So work done should be equals to minus k by 2. Finally is now x2 square minus x1 square. Okay. So in the other way, if I want to calculate the work done from A to B, from here to here, so here to here means x2 is now final. So for the blue arrow, work done is how much? Minus k by 2 into x2 square minus x1 square. If I want to calculate from A to C in this situation, final begin x2 and initial is x1. So work done is how much? Minus k by 2 into x2 square minus x1 square. Okay, that is what I am saying, that if I move the spring from A to B, if you compress by x1, then further compress by x, then the work done is same as compressing the x1, then elongating x2, A to C. So this statement, look after this. So if I compress the string from A to B or compress the string from A to C, both will be the same one. That means it depends only on the initial and final position. So xi and xa for the magnitude of the deformation, no matter if these are compressions or expansions. Because answer remains same. Only is the initial and the final.